Welcome to this lecture on engineering fire safety and statutory compliance. In this session, we'll examine a comprehensive structural and tactical framework designed to counteract the chemistry of fire. We will cover how smart architectural design, integrated active suppression systems, and strict legal compliance come together to protect life, preserve structural integrity, and ensure full regulatory alignment. To effectively engineer fire safety systems, we must first look at the chemistry of combustion. At its core, fire is a rapid chemical oxidation process represented by the fire tetrahedron, consisting of fuel, heat, oxygen, typically around 21% in standard air, and the uninhibited chemical chain reaction. The fundamental principle here is absolute. Removing any single component of this tetrahedron instantly terminates the fire. Every statutory building code, active suppression system, and tactical firefighting intervention is mathematically engineered to target and eliminate one or more of these four components. Once we understand the chemistry of fire, we must categorize the specific threat based on its fuel source. Standard engineering frameworks divide fires into 6 key classifications. Class A, ordinary solid combustibles, including wood, paper, cloth, and plastics. Class B, flammable liquids like gasoline, oil, paints, and solvents. Class C, flammable gases, such as propane, natural gas, and methane. Class D, combustible metals, including magnesium, titanium, and sodium, which require specialized dry powder agents. Class E, electrical hazards involving energized equipment like motors, transformers, and building wiring. Class F or K, high-temperature cooking media, such as commercial deep-fat fryers and animal fats. Properly identifying the fuel class is essential. To tie these concepts together, we view fire protection as a series of concentric defense layers built around the chemical threat. At the center is the fire tetrahedron itself. This represents the chemical core, where engineered safety targets fuel, heat, and oxygen. The first protective ring is structural fire protection. This encompasses our engineered passive and active systems, designed to disrupt that chemical reaction automatically. The second ring covers human tactics and egress. This relies on human intervention, including rapid evacuation, proper extinguisher protocols like PASS, and first responder action. The outermost ring is the legal framework, encompassing standards like the NBC, NFPA, and Factories Act. This outer layer enforces the design and mandates compliance. Structural stability. Load-bearing walls and columns must maintain a 2 to 4 hour fire resistance rating, sustaining load-bearing capacity R, integrity E, and insulation I, under standards like ISO 834 and ASTME 119. Compartmentation limits. Unsprinklered floor areas are strictly capped between 750 and 1,500 square meters. Installing full sprinkler coverage permits trade-offs, expanding allowable compartments up to 3,000 to 4,500 square meters. Vertical and duct isolation. Service shafts require fire stopping at every floor level using intumescent sealants, while automated fire dampers with fusible or actuated links seal off HVAC penetrations during a thermal event. Opening protectives. Access points rely on fire door assemblies rated for 1 to 4 hours, continuous smoke seals to prevent. Where passive barriers contain a fire, active systems step in to detect, alert, and suppress the threat across 3 phases. Detection and alarm, NFPA 72 IS 2189. Manual call points are placed within 22.5 to 30 meters of any point. Smoke and heat detectors protect key rooms and ducts, while voice evacuation is required for assembly spaces and tall structures. Suppression, NFPA 13 IS 2190. Automatic sprinklers are mandatory for basements over 200 square meters, institutions, and buildings above 15 meters, keeping a 1 bar minimum residual pressure. Manual suppression. Wet risers feed landing valves and 30-meter hose reels and stairs, while external hydrants sit on a ring main every 45 to 50 meters. Primary goal. Passive systems aim for containment by STAR-VNG fuel and oxygen, while active systems focus on suppression by removing heat. State of operation. Passive protection is always present and requires no activation. Active protection depends on detection and mechanical actuation. Key components. Passive relies on firewalls, fire doors, and intumescent seals. Active relies on sprinklers, manual call points, wet risers, and alarms. Failure risks. Passive systems fail due to human error, like propped open doors or unsealed duct penetrations. Active systems fail due to mechanical issues, like pump failure, closed valves, or low water pressure. Governing codes. Passive design is governed by structural provisions in NBC Part 4. Active design falls under standards like NFPA 13, 72, and 10. Safe occupant evacuation is governed by precise geometric calculations across 3 distinct egress zones. Zone 1, exit access. The path to an exit. Maximum travel distance ranges strictly from 22.5 meters in high-hazard or educational spaces to 45 meters in sprinklered offices. Zone 2, the exit. A protected enclosure, like a stairwell. Buildings with over 50 occupants require at least 2 independent exits, while stairs above 15 meters must be pressurized to 25 to 50 pascals. Required width equals total occupant load divided by capacity factors, 75 persons per meter for doors and 50 per meter for stairs. Zone 3, exit discharge. The final exterior path leading to a public way, which must remain completely unobstructed. Statutory compliance balances building use with municipal location across designated occupancy groups and fire zones. Occupancy groups, groups A through D, prioritize life safety with wide egress corridors. Groups E and F manage high fire load densities, while groups G through J require specialized containment like explosion venting and deluge valves. Municipal fire zones. Zone 1 covers low-risk residential and commercial developments. Zone 2 applies to moderate-risk light industrial areas. Zone 3 designates high-risk heavy industrial and chemical facilities, requiring strict buffer zones. Mapping a facility's occupancy profile against its fire zone determines the precise active and passive systems needed to maintain statutory compliance. Industrial environments handling high-risk hazards require strict statutory adherence across operational and facility controls, Factories Act, and OSHA standards. Mandatory evacuation drills must be conducted and logged every 6 months, with emergency exit signage clearly illuminated in both local languages and English. Secondary containment. Flammable liquid tanks must feature bunded containment capable of holding 110% of the largest tank's volume. Classified zones. Electrical equipment operating in hazardous zone 0, 1, or 2 locations requires flame-proof EXD ratings to prevent ignition. Emergency planning. Facilities must maintain fully developed on-site and off-site emergency plans to coordinate internal response and external municipal support during severe incidents. First responder manual tactics rely on selecting the correct extinguishing agent for each fuel class. Selection matrix. Water serves Class A combustibles. Foam targets Class A and B liquids. CO2 handles Class B and C gases, while dry powder covers Class A, B, C, and D hazards. Specialty agents. Class D metal fires require specialized dry powder to smother intense heat. Class F cooking oils require wet chemical agents to induce saponification, turning hot fats into soap. Proximity rule. NFPA 10 mandates a maximum travel distance of 15 meters to any portable extinguisher. Fatal errors. Never apply water to Class B flammable liquids, which causes fire spread, or Class E electrical hazards, which creates electrocution risks. When deploying a portable extinguisher, operators must execute the standardized pass sequence to maximize tactical efficiency and safety. P. Pull. Pull the safety pin to break the tamper seal holding the operating lever in place. Aim. Aim low, pointing the nozzle directly at the base of the fire, targeting the solid or liquid fuel source rather than the rising flames. S. Squeeze. Squeeze the handle or lever to release the suppressing agent under controlled pressure. S. Sweep. Sweep side to side across the entire base of the fire until combustion is completely extinguished and the threat is neutralized. Statutory compliance is managed through a continuous regulatory life cycle, progressing across 4 distinct phases. Phase 1, provisional NOC, issued during the initial plan approval stage before construction to verify architectural fire safety blueprints. Phase 2 and 3, construction, joint inspection, and final NOC. Following system installation, authorities conduct functional testing of hydrants, alarms, and sprinklers. Occupancy is illegal without this final certification. Phase 4, periodic audits and renewal. Compliance requires ongoing renewal, every 1 year for commercial and industrial facilities, or every 3 years for residential developments. Core audit checklist. Regular audits verify main, diesel, and jockey pump functionality, clear egress routes, extinguisher pressure gauges, etc. Failure to maintain fire engineering standards carries severe statutory, criminal, and financial consequences. Statutory enforcement powers. Fire authorities hold legal authority to issue stop work orders, physically seal non-compliant buildings, disconnect electricity and water for life-threatening hazards, and revoke occupancy certificates. Criminal liability. When statutory violations, such as locked exits or disabled alarms, result in fatal incidents, building owners, safety officers, and management face criminal prosecution for culpable negligence. Insurance implications. Insurers routinely reject fire damage claims if investigation proves the facility operated without a valid fire NOC or failed to properly maintain mandated fire protection systems. In conclusion, life safety relies on uniting engineering principles with legal compliance under a single unified framework. Synthesis statement. Fire safety is not a collection of arbitrary regulations. It is a precise, mathematically engineered system designed specifically to break the chemical chain reaction of fire. The mandate. By seamlessly integrating passive structural containment, active mechanical suppression, and unhindered egress pathways, we fulfill our statutory duty of care. Legal shield. Overarching legal certification, like the valid fire NOC, serves as the ultimate protective shield, ensuring all systems function in harmony to safeguard life and property. Thank you.